Isabella Garcia. I'm in CHEM 119, section 546. I'm going to be talking about and demonstrating significant figures. So first of all, what are significant figures? Significant figures are the digits in a number that carry meaning in terms of precision. They are used to keep track of the quality of measurements. What does this look like? So there are rules, and number one, non-zeros are always significant. Number two, any zeros between two significant digits are significant. Number three, a final or trailing zero in the decimal place are significant. Addition and subtraction, you count the number of significant figures in the decimal place of each problem. You round the answer to the least number of significant figures in the problem. Multiplication and division, the least number of significant figures in any number of a problem determines the number of significant figures in the answer. Scientific notation, all digits comprising n are significant only, so the 10 and the x are not significant. So what does this look like? So for example, in this problem you're adding, and so you have to look at the smallest number in the decimal place. So that means that your answer will have one significant figure in the decimal place. So you would add like normal, you would get this answer, but you see that it's not the right amount of significant figures. So you can round and you get 30.0, and this has one significant figure in the decimal place. But another rule applies here. So trailing zeros are significant after a non-zero number. So this is a non-zero and these are the trailing zeros. They're significant. So number two, if you multiply these numbers, you want to have the smallest amount of significant figures in the smallest number in the problem. So for example, if you add, you get this number, and this would be the smallest number in the problem, and it has three significant figures. So you want your answer to be three significant figures. So you see, you take it and you get 34.1. Number three, you divide and the same rules apply. So this number has four significant figures. This has five significant figures. So you use this one for your answer. So you get this when you divide, and you notice how there is 6 numbers in this answer, but you have to remember that leading zeros are not significant, but also a zero between two non-zeros are significant. So this number has 1, 2, 3, 4 significant figures. And finally, for the last problem, if you multiply, you would get this answer, but you see that it is too big because this is the smallest amount of significant figures, so you would have to change this into scientific notation. So you would get 2.59, so you round this and it becomes a 9. 2.59 times 10 to the power of 3, 1, 2, 3, and you get three significant figures.